So next we have Vagrant Cascadian and with Re-Py-Ducible Builds.
Hello, everyone. Good to see you and most of your face. Let's see. As he just said, I'm Vagrant Cascadian. I work with the Reproducible Builds project, and I'm very excited to kind of edge into a space I'm not usually involved with. So I've been mostly involved kind of as a downstream from Python. So I work with Debian a lot. I've done a little bit of Python programming, but really like most of the stuff I did was in the Python 1 and early 2 days. So I'm not super savvy with modern day Python, but I use Python in a lot of projects, and I've submitted countless patches to Python projects in order to make them reproducible. And so I also work a little bit with the GNU Geeks project, which is a little bit different kind of a distribution. And I would love, if anybody wants to talk to me about PyPy, I don't know a lot about it, but I would love to sort of edge into some reproducible builds work in that space. So what the heck is reproducible builds? Basically, it's the crazy idea that if I build something and somebody else builds it, they get the exact bit-for-bit identical same thing. That bit-for-bit identical part is really helpful because it makes comparison trivial and easy. So we've kind of spec'd out a definition and some toolings in the Reproducible Builds project to help people achieve that. So in the Python landscape, at least in Debian, it's pretty achievable. The vast majority of packages in Debian, at least that the Debian Python team maintains, are reproducible. We're looking at 94% that's over 2,000 packages, well over, and that's not all of the Python packages in Debian. That's just like one team that focuses on Python. So that's pretty exciting. But Debian kind of cheats a little bit. So the .pyc files that Python produces normally include timestamps. And so if you build it literally a second later, even though if everything else is the same, it's not going to come out bit for bit identical. So Debian kind of cheats by we build packages, and then at the time you install the package, it generates all the relevant PYC files. So that's kind of a little cheat, but it's not so crazy. One of the other projects I work with, GNU Geeks, it actually uses the unchecked hash feature of when it compiles the PYC files, and I think it has a fairly good success rate. And in recent versions of Python, these features were introduced a while back, but I think there have been some bugs. But I believe in fairly recent versions of Python, out of the box, if you set the source date epoch environment variable, then they come out reproducible. It defaults to one of the hash methods. So what is source date epoch, you may wonder? So that's just essentially a specification to say, if you're building a project and you really need to put a timestamp in there somewhere, use this timestamp. Don't use whatever it happens to be when you build it. This is the timestamp we want you to use. Ideally, try to avoid embedding timestamps at all, because this is using source date epoch. It's a kind of ugly workaround. It works. It does the job. But you basically set an environment variable to the number of seconds since 1970, and then various tools can consume that. And so a real-world example of that is with the wxmplot package. One of my colleagues submitted a bug in Debian for this, and one of the things he had to do with this one is to switch from using datetime, which is just doesn't tend to be very easy to make reproducible, and then provide a string that consumes the source date epoch environment variable, and then sets a fallback to if it's not set, well, yeah, go ahead, use the current time. But if it is, and this particular patch really hits one of my pet peeves. So a lot of projects, they really want to automate the copyright information on their project because they don't want to go around manually updating the year every time they change a file, blah, blah, blah. But the build time is not a valid copyright timestamp. You don't generate new copyrightable material just by building it. That is the definition of non-copyrightable material. It's auto-generated from the source code. So in my opinion, this is a serious anti-pattern, and it'd be more appropriate to manually update all of the years and all of your code files, whatever. This one ended up getting embedded in the documentation. Or not a lawyer, but I think in many jurisdictions, you just don't have to include the year. You assert copyright on it, and you can use the revision control system to define when any particular piece of code was relevant, what year it was created in, whatever. So that's one of my biggest pet peeves, is people just injecting the data in for not only like whatever, like, okay, sure, you want a date, but it's actually wrong. It actually generates the wrong information. So you can't create copyright by building software, at least unless you're talking to AI people, but they're kind of crazy. So this is an example of a fairly simple one. 80 to 90% of the problems with reproducible builds are people injecting timestamps in one form or another, a date, a year, the full timestamp down to the second. So if you can keep an eye out for, hey, do I really need this timestamp in there? Maybe if we need some time-specific information, we can check the build log in the CI system, or whatever kind of other avenues, but don't embed it in something that you then ship. And kind of going back to the source date epoch, you can actually set that to a meaningful value, say the last commit in your revision control repository. So rather than whenever this happened to be built, you can actually give it some other kind of meaning, or just purge timestamps entirely. That'd be great. So this is another kind of more weird, obscure one. I was tempted to actually try and use a PyImpress to present this presentation because I go into several bugs on it, but I didn't get around to that. But basically, in this one, it sets a default value for the timestamp, and then it got embedded the memory. How do I describe this? So the object gets embedded into as the memory space that object created ended up kind of displaying in the documentation. So that's kind of not right. So one of the workarounds for this is to delay when it actually evaluates it. So rather than defining it in the function, you actually define it as none. And then in the function itself, that's when you call it. So at runtime, it's going to generate that, but it doesn't spit that out into your documentation if you're generating the documentation from the Python itself. And my colleague thought this was good enough, but I noticed some other problems in this. The documentation also embedded the running kernel version. So the Linux kernel, it has a version. On any Unix system, you type uname A and you get a whole bunch of stuff. But that seems kind of overkill. You shouldn't have to run some old kernel in order to reproduce the software. So I recommend in those kind of situations, this is the code that actually embedded that stuff. So platform release, platform version. Arguably platform system, maybe you wouldn't want to embed that. That's more debatable if you wanted to do cross-compiling on some other system. But basically, I'm just like, forget it. We don't need that information in here. We know where this was built, or you can check the build logs. There are any number of other ways you can find that information. So another approach would be to sanitize the documentation after the fact, because I think, again, this is documentation generated by running the program itself. So that'd be another approach, but I'm totally cool with just redacting stuff or maybe even leaving it out entirely, not super important. Another really cool thing with PyImpress, I'm not even sure if I'm pronouncing that right, but so it helpfully translated the documentation when the locale settings were set to some other locale. You probably want to if you want translated documentation, you should probably generate that explicitly, not whatever happens to be the locale of the running build environment. And this is kind of what it came out. I kind of stripped out the XML markup, right? Like that's obviously like some other language. Seems vaguely Latin family language. Basically, the workaround was to just ensure the build was done in a consistent language environment. Might also be a good approach to go into the upstream build system and actually patch it to only use a specific known locale. If the default is English, for better or worse, maybe you should always generate your documentation as English and set up some other system to generate translated documentation. So those are a few examples of just weird things that can end up in your build that you didn't want to. Timestamps. I'm going to repeat that one over and over again because that's like main problem. But yeah, translated strings, random memory stuff that just ends up dumped in your documentation because of how you initialized a function. So those are some of the main examples. Another thing is at least in Debian recently, we've started doing some tests of building things against the actual packages we ship in the archive. And hooray, Python itself is reproducible in our archive. So we have successfully reproduced something that we ship that people actually run on their system. This is pretty exciting for us because up till recently, we've been running these other systems which just kind of run a build and then run the build again. And that version, for whatever reason, isn't coming out bit for bit identical. So there are some weirdnesses left in there. This system, rather than the one where it does come out reproducible, is actively trying to like shake things up. It changes all sorts of random things in the environment, changes locale settings. It changes the niceness value that we run the builds at. Runs it as a different user. It does all sorts of things. And so that's a really good like CI sort of thing you can do to test for reproducibility is when you build in an environment, there are kind of two philosophies, right? One, you normalize as much as you can in the build environment. And the other is, hey, let's actively find problems with this stuff. And oftentimes you find things like, oh, some weird random value ended up in the documentation. And you just wouldn't notice it because you're sifting through, several hundred pages of documentation with each build. That's kind of awkward. But if you run a CI system that actively, tries to break things, you can sometimes find it's kind of like the fuzz testing of software building, right? So you can change things around a bit. The image in this slide here is some output from a tool we call diffoscope, and it's kind of like the super amazing. How many people in here have used some sort of diff tool? Yeah, all right, that's a lot of hands. Great. So diffoscope is like diff, but way more impressive. So it will like go and look and see, and it'd be like, okay, this is a zip archive. Let's unpack that zip archive and compare it against the files within the zip archive. Oh, these two files look similar. Let's compare those files. Maybe inside of that you've got a CD image file or something, and then it unpacks those image files and then compares it and tries to render it into the closest thing to human readable it can figure out. And that's all written in Python. For example, on an earlier version of these slides, I ran diffoscope on it, and I expressly broke the source state epoch thing in order to get a useful result here. But I ran it on an earlier copy of these slides and an earlier copy, and sure enough, there were differences. So it's a pretty simple tool to use. Much like diff, you run diffoscope, you pass it a couple arguments, and it compares those things. So it's a recursive diff, if you will. It can run some, generate like HTML-like output with like fancy highlighting and stuff. And it supports a few file formats. This is a not exhaustive list because it just keeps adding more, and this is probably stolen from a slide from 2016. I know for a fact it's added more than this, but obviously we're not going to get more onto this slide. So that's about it there. And if you want to play with it, but you don't want to install it, you can try it online, try.diffoscope.org. It's pretty useful. It's a little bit limited. We can only process so information. Don't go uploading gigabyte large files. I think it has a file size limit. But that's like an easy way you can just try it out. Take two files that are similar but are different, upload it up there, and you can kind of experiment with it before you want to install it. Because it does pull in a lot of dependencies because it supports so many file formats. Another tool we use in reproducible builds is reprotest. So it's a tool that will basically build something and then build it again, and it'll change a bunch of things. It might shuffle the order that files come out of the file system. It might change the domain name, the user, the time, all those sorts of things. And another thing it can usefully do is just systematically go through all of the different variations and see if, to isolate what type of an issue is it. Is this a timestamp issue? Is this a username issue? Is this a whatever? It'll just systematically go through and perform multiple builds with each of those things. And unfortunately, it really needs some help maintaining it. Happens to be written in Python. I don't know if you know any Python programmers. But yeah, some while ago, we embedded some code in it. And so a lot of the virtualization backends aren't working anymore because they updated the upstream code. And we haven't upstreamed the code in reprotest. It's a bit of a mind bender of a piece of code, but if anybody's interested in an interesting project, I would love to have some help on that. And I think, well, we're running a little fast here, but yeah, so we could use our help in all sorts of manner of ways. We got to keep the lights on, as it were. We also need people who are interested in working on these projects. There are some bite-sized pieces to tackle. There are some huge pieces to tackle, if that's your thing. Yeah, and another thing I'd really like some help with is I'm mostly familiar with packaging Python stuff as a downstream developer in Debian, less so in Fedora, but the same kind of idea in GNU Geeks, in NixOS, whatever, all sorts of different operating systems. But I'd really be curious. I know PyPy distributes some binary objects from time to time, or if there are other systems for distributing Python stuff. It'd be really great to see some effort working with those folks to actually do reproducible builds kind of work in the PyPy space. So if you are familiar with PyPy, I would love to chat with you. Anytime during this conference. Catch me. I'll be around mostly in the afternoons. But yeah. And this is where I would normally ask for questions, but there are no questions. So I will have to just speculate what your questions might be at this point. Let's see. So, that's a good one. So diffoscope, it's a Python program. It's fairly well maintained, unlike reprotest, but we can always still use some help. It, for a large part, does call out to other tools to do a job. You know, it will take like a program that parses zip files to do that, but there are some Python native implementations of stuff. And everything's very packed out into modules. So it's very, there's a module for a specific test for a specific file type. There's a module for, the actual comparison between different file types. I don't have much experience running it outside of the scope of a distribution. If that's your thing, I don't know, playing around in virtual M's or whatever the coolest stuff is these days. I'd be curious how it runs in those environments. If you want to play around with it, try to break things. Similarly, I'll often build it in both Debian and Geeks, and they come up with different bugs. So yeah, just testing diffoscope in more environments than we currently do. The Reproducible Builds project has numerous contributors from many different distributions, including some of the BSDs and several Linux-based distributions. But we haven't really edged into the domain-specific packaging space like PyPy and whatnot. So would love to get more interaction there. But yeah. Yeah, I know one of the folks working on Python security did some work to make the released tarballs reproducible, which is pretty cool. It looks like I was kind of surprised because we just started this new Debian thing. I was really surprised when Python came out reproducible. Happy, of course, but yeah, so there are probably some other things because if you vary lots of stuff, it doesn't come out reproducible. So anybody who wants to work like on the actual Python itself or some of the other Python implementations, I think there's also another one called PyPy, which is really confusing, and various other Python implementations. Would love to like poke at those. I think there's a talk about MicroPython later tomorrow or something. That would be interesting. But yeah, let's see. Yeah. Well, suppose we could just call it. All right. Thank you all.